Okay, so now let's talk about the special words or phrases which we use in order to connect these statements together. So it's about special words or phrases. Words like or, like and etc. and etc. So some of the connecting words which are found in compound statements like and, or, etc. are often used in mathematical statements, and these are called connectives. So these words are called connectives. That's a good name for these words, connectives. When we use these compound statements, it's necessary to understand the role of these words. We discuss them here. So the first word that we want to discuss here is the word and. So let's say that you have a statement, for example, P is a point occupies a position and its location can be determined. A point occupies a position and its location can be determined. So this statement can be broken into two components as Q, for example. A point occupies a position. A point occupies a position. And also its location can be determined. Its location can be determined. And of course they are connected. The connective used here is basically and. So we observe that both the statements are true. So a point occupies a position is true, and also its location can be determined. It's true, meaning that the location of a point can be determined, which is true, and also a point occupies a position, which is true. Let us look at another statement. So here you need to pay attention to the fact that both of these statements are true and the connective used is and. And hopefully we will come to some conclusion about these here. So we have another statement as, for example, P, 42 is divisible by 5, 6, and 7. 42 is divisible by 5, 6, and 7. So this statement has three components. The components of this statement are Q, which is 42 is divisible by 5, is divisible by 5. R, for example, 42 is divisible by 6, and S, let's say 42 is divisible by 7. Of course, you know that this is true. 6 times 7 is equal to 42. This is also true, but this is false. And the connective used here is and. So the first one is false, while the other two are true. So now here is the rules that we have. Here is the rules that we have regarding the connective AND. Rules regarding the connective AND. That is basically rule number 1 is the compound statement with AND is true if all of its component statements are true. So the compound statement with AND is true if all of its component statements are true. If all of its component statements are true. This is important. Meaning that, for example, when you say 42 is divisible by 5, 6, and 7, the component statements of this compound statement are these 3, and of course you see that this one is false, so of course this cannot be true. This is also this will also be false. Rule number 2 is the component statement with AND is false if any of its component statements is false. This includes the case that some of its component statements are false and all of its component statements are false. So the component statement with AND is false if any of its component statements is false. I think this is wrong. The sentence is wrong. I think what they meant to write was that, and this must be a mistake. I think what they meant to say is that the compound statement, they have written the component statement. The compound statement with AND is false. That makes sense. It is false if any of its component statements, is false, meaning that a compound statement with AND, for example, this compound statement here, this is false if any of the component statements is false. Now, for example, in this case, you can see that over here, this component statement is false, and so the compound statement is false. And this includes the case that some of its component statements are false. Some of its component statements are false, or all of its component statements are false. So that is basically simple and easy to understand. So rule number 1 related to rules regarding the connective AND, rule number 1, you can say that the compound statement with AND is true if all of its component statements are true. All of them have to be true so that the compound statement is true, if there is AND in there. And the compound statement with AND is false if any of its component statements is false. This includes the case that some of its component statements are false or all of its component statements are false. So these are simple to understand. So as an example, let's say that you have, for example, you want to write the component statements of basically these compound statements and check whether the compound statement is true or false. So the compound statement that we have is, for example, a line is straight and extends indefinitely in both directions. A line is straight and extends indefinitely in both directions. Now this is a compound statement, and the component statements of this compound statement are basically P. You can say a line is straight. A line is straight, which is true. This is true. A line by definition is straight. And Q, a line extends indefinitely in both directions. A line extends indefinitely in both directions. This is also true. So since both of the component statements are true, then you can say that the compound statement is of course true. These are based on the definition. I'm saying that these are true, because if something has to be a line, it has to be straight, and if something has to be a line, it has to extend indefinitely in both directions, unless it's a line segment, for example, or it's a ray or something like that. Otherwise, it will extend in both directions by definition. Now, as another example, let's say that 0 is less than every positive integer and every negative integer. 0 is less than every positive integer and every negative integer. So 0 is of course less than every positive integer, but it's not less than every negative integer. So the component statements are P. 0 is less than every positive integer, and Q, 0 is less than every negative integer. Okay, so this is true, this is false, so this is false. Basically the third statement that we have here The third statement that we have here is all living things have 2 legs and 2 eyes. All living things have 2 legs and 2 eyes, which is not true, of course. The component statements of this compound statement is all living things have 2 legs, and Q, all living things have two eyes. So you could, if you really search, you don't really have to search so much, but if you look at living things, you can find at least one living thing that has no legs, basically. So so you cannot say that all living things have 2 legs. This is false. And there are some creatures that have only 1 eye, so that's also false. So this is false. So the 2 component statements are basically all living things have 2 legs, all living things have 2 eyes. Both these statements are false. Therefore, the compound statement is false. Now consider this example. A mixture of alcohol and water can be separated by chemical methods. A mixture of alcohol and water can be separated by chemical methods. Okay. Now, of course, this is not a compound statement. This sentence cannot be considered as a compound statement with and. Your and is over here, but this and is not making this sentence a compound statement. This and is a part of this phrase which says a mixture of alcohol and water. So that doesn't mean that it's a compound statement. And so this leads us to the important note that do not think that a statement with and is always a compound statement as shown in this example. Therefore, the word and is not used as a connective. Over here, and is not used as a connective. You understand, based on the context and based on the sentence, you understand whether and has been used as a connective or as just a part of a phrase in a sentence. So for example, and in this sentence is not a connective, and it doesn't make this sentence a compound statement. So that's all about and. Now, let's talk about a little bit about or. Okay, so now about the word or. Okay, so I had to actually read a little bit about the word or, because or is a little bit, there are different types of or. There is inclusive or, there is exclusive or, and so on and so forth. There is all kinds of rules for or, so we need to talk a little bit about or. So there is an example over here. In this discussion starts with an example, and then based on these examples we will kind of derive some rule. So there is a statement that says that, for example, you have a statement P, two lines in a plane either intersect at one point. So it says two lines in a plane either intersect at one point, or they are parallel, or they are parallel. So you can see that you have the word, you have the connective. I suppose this was called connective. You have the connective or over here. So or, basically what this means is that basically this is of course a compound statement. And the compound statement, of course, you can break this up into two component statements and write them as component statements. But before we do that, let's go through the information that we have here, and then if it's required, we will do other things as well. So basically, if you look at this sentence or this statement, you will see that the statement is true, because two lines in a plane is in a plane either intersect at one point or they are parallel. It makes sense, meaning that if you have two lines in a plane, suppose that we have this plane over here, this XY plane, for example, the paper plane that I'm writing on, a two-dimensional plane, and both of these lines are in the same plane. So now these two lines are parallel. So since the two lines are parallel, they're not going to intersect one another at any point on this plane. There can be one more case here as well, and that is if you have these two lines, and if the two lines are not parallel, so they intersect one another at this point, at this point of intersection. So this, what this means, what this statement means is that this means that if two lines in a plane, that if two lines in a plane intersect, which was this case over here on the right, then they are not parallel. If the two lines intersect, then they are not parallel. And then they are not parallel. And alternatively, you can also say that if the two lines are not parallel, then they will intersect at one point. So now, of course, this is not a very good explanation you would get. I mean, the only thing that this explanation does for you just confuses you, because I was confused in the beginning, and even now I don't understand really the explanation. So let's just not think about this explanation. As long as this statement makes sense to you the way that I explained it, that's more than enough for now, and then later on we'll get to some rules and you will understand the whole thing completely. So what this means is that in simple language is that two lines in a plane either basically intersect at one point, something like this, or they are parallel. So that is basically the meaning of this sentence, of this statement, and of course it is true. So So now the confusion related to the word or, I was confused for many years, many years, when I went to college in India. Basically, the word or is used everywhere in mathematics, of course, and you're supposed to understand it. And it's used. It is basically used in a very it is used based on the rules and regulations, based on which you're supposed to use the word or. Not like the English language, not like the way that you use the word or in the English language. Not necessarily so. So, basically the word or is used in two ways in the English language. So in the English language, or is used in two ways. Or is used in two ways. So as an example, let's take a look at this statement. The statement is, for example, P, an ice cream or Pepsi is available with a thali in a restaurant. So it says an ice cream or Pepsi is available with a thali, is available with a thali. Thali is basically some sort of meal in India. It's like it's on a plate, on a round plate, and there is all of these little things in little bowls all around the plate, and then there is some bread in there, and it's just some sort of meat. With a thali in a restaurant. So what this means is that the person who does not want ice cream can have a Pepsi. A person who does not want a Pepsi can have ice cream. But it's not like the person can have both of them. So what that means is that basically the meal that you order is a thali, right? And with a meal as a dessert, I would say, or as a drink or whatever you want to call it, you get either ice cream or Pepsi, but not both of them. So that is the meaning that someone who does not want a Pepsi can have ice cream, okay, and vice versa, of course. Meaning that the person who doesn't want, and of course vice versa. And so a person cannot have both ice cream and Pepsi with, let's say, one meal of thali. So this is called exclusive or. This situation over here is called exclusive. This situation over here is called exclusive or. So what exclusive or, again, I repeat the situation. It says that an ice cream or Pepsi is available with a thali in a restaurant. And this or over here is basically an exclusive or. And what that means is that the person can have either ice cream or Pepsi with his meal, but not both of them simultaneously. meaning that someone who doesn't want Pepsi gets ice cream. Someone doesn't want ice cream gets Pepsi, but not both of them at the same time. That is called an exclusive OR, meaning that if you choose this one, you're excluding the other one. You're excluding this one. And if you choose this one, you are excluding the other one. That is called an exclusive OR. Now, there is another type of OR which is called an inclusive OR. And how that works is that, for example, let's take another example. It says that a student who has taken biology or chemistry, a student who has taken biology or chemistry can apply for MSc, MSc, this is Master of Science, MSc Microbiology Program. Microbiology Program. That must be some, that of course must be some course. It's a Master of Microbiology Program, some course over here. Now the point over here is that basically you have an OR over here, and this OR in this case is called an inclusive OR. It's called an inclusive OR. So the sentence or the statement, if you want to call it a statement, is that a student who has taken biology or chemistry can apply for MSc Microbiology Program. What that means is that if the student has taken biology before, can apply for MSc Microbiology Program. What it means is that if the student has taken chemistry before, he or she can apply for the MSc Microbiology Program as well. And what it also means is that if the student has taken biology and also chemistry, both of them, can also apply for MSc Microbiology Program as well. So there are 3 different cases. Either he has taken biology before, only biology before, or he has taken chemistry before and only chemistry before, or he has taken biology and chemistry, both of them together before. In all of these 3 cases, he can apply for MSc Microbiology Program, and he would have no problem applying for the course, right? So this case represents an inclusive OR. That means that if you choose this one, that includes the other choice as well. And if you choose this one, that includes again the other one as well. But you cannot exclude both of them. Either one of them or both of them together you can choose, and you would have no problem with, and that's basically how inclusive OR basically works. Okay, so here we mean that the students who have taken both biology and chemistry can apply for the microbiology program, as well as the students who have taken only one of these subjects, right? So in this case, we are using inclusive OR, which is what we have written over here. And it's, of course, important to note the difference between these 2 ways, because we require this when we check whether the statement is true or not. So we will see how that works, of course. So in order to understand that, let's take a look at some examples. So what we want to do in this example is that for each one of these examples or statements, we want to determine whether an inclusive or an exclusive or has been used. Okay. So let's see what the examples are. So for example, as a first example is we have to enter country. To enter a country, you need a passport or a voter registration card. You need a passport or a voter registration card. So to enter a country, you need a passport or a voter registration card. So here basically you can see that basically the or that we have used over here is an inclusive or, because if you have the passport, you can enter the country. If you have the voter registration card, you can enter the country. If you have both of them, you can still enter the country. So this is an inclusive or. This is an inclusive or. So the second example that we have is the school is closed if it's a holiday or a Sunday. The school is closed. The school is closed if it is a holiday or a Sunday. So over here what we have is that the school is closed if it's a holiday or a Sunday. So what it means is that if it's a holiday, the school is closed. If it's a Sunday, the school is closed. And so let me see what the reason here is. Here also or is inclusive since school is closed on holiday as well as on Sunday. Meaning that it can be a Sunday as well as a holiday, or it can be a holiday, or it can be a Sunday. So this or again is an inclusive or. This is again an inclusive or. Now, basically statement number 3 is two lines intersect at a point or are parallel. Two lines intersect at a point or are parallel. So two lines intersect at a point or are parallel. The or that we have used here is an exclusive or. Exclusive or. And the reason for that is that basically two lines will intersect at a point, or basically two lines are parallel, but both of them cannot be true at the same time. So this is an exclusive or. meaning that the two cannot happen at the same time. The lines cannot be parallel and still intersect at a point, so this is an exclusive OR. Or if you say that, for example, students can take French or Sanskrit as their third language. Students can take French or Sanskrit as their third language. So here the rules, basically, let's say that the rules are the student can take French or Sanskrit, but he's not supposed to take both of them, or he's not even allowed to take both of them. He can choose either French or Sanskrit. So then you can say that this OR is an exclusive OR, meaning that both of these cannot happen at the same time. Okay. So now the rules for OR, is that the rules for compound statement with OR, let's say. Rules for compound statements with OR. The rules are basically this. So rule number 1, a compound statement with an OR is true. A compound statement with an OR is true when one component statement is true or both the component statements are true. When one or both component statements are true. So it says that the compound statement with an OR is true when one component statement is true or both component statements are true. Meaning that, for example, in the case of these examples over here we said that basically the student can take French basically as their third language or Sanskrit as their third language. So one of them is true, right? Of course, both of them in this case are true, but that's not a good example to make the point here. No, that's not a good example over here no, but basically a compound statement with an OR is true when one or both component statements are true. Meaning that if you're using an exclusive OR, this is what it means. This is basically a little bit confusing about this OR. So when you're using an exclusive, you're using either an exclusive OR or you're using an inclusive OR. So when you're using an exclusive OR, basically that would be a situation like this. Let's say you're using an exclusive OR. So you have a situation like this. So in in an exclusive OR, basically okay, so now, well, I did try to explain this part, but I couldn't. Well, this part is a little bit messy, okay? You need to bear with me until we get to the end of this, and then hopefully you will understand it yourself. Now so please do bear with me until we get to the end of this. So rule number 1, it says that the compound statement with an OR is true when one or both component statements are true. Okay. Number 2, a compound statement with an OR, a compound statement with an OR is false when both the component statements are false. Both the component statements are false. So what that means is very simple, of course, but again, we will have to basically do a couple of examples and write out the component statements, and then we will be able to talk about that. Otherwise, we would just simply confuse ourselves. So it says that if you have a compound statement with an OR, it's going to be true. The statement is going to be true if basically let's say you have two components. Let's say you have a compound statement. Let's say that you have a compound statement and it has basically two component statements, right? So this is a compound statement. This is the two component statements related to this compound statement, and there is an OR over here. So this compound statement is going to be true if either this one is true or this one is true, or both of them together are true, or both of them simultaneously are true. Meaning that if only this one is true, or if only this one is true, or if both of them simultaneously are true, then you can conclude that the compound statement is true. And now let's say you have another compound statement over here with an OR, and and your compound statement has two component statements. Now so basically we said that the compound statement with an OR is false. So this is going to be false when this component statement is false, and also this component statement is false. So if none of them is true, then this is going to be, if none of them is true, then of course this is going to be false. If any of them is true, then this is going to be true, and also if both of them are true, this is going to be true. So that's basically the whole story. Now let's go a little bit further and do a couple of examples to understand this a little better. So suppose that, for example, we have the statement that we had earlier. So we said that basically as a compound statement, we have two lines intersect at a point, or they are parallel. Two lines intersect at a point, or they are parallel. Now let's see how we can understand this. So the component statements of this compound statement, the component statements of this compound statement are, let's call them, for example, Q and R. And Q and R are basically two lines intersect at one point. Two lines intersect at one point, or two lines are parallel. Or two lines are parallel. Now, basically, when Q is true, R is false. When Q is true, R is false. And when R is true, Q is false. Meaning that two lines cannot be simultaneously parallel and also intersecting at one point. So when Q is true, R is false. When R is true, Q is false. Therefore, the compound statement is, meaning that in any case, one of the components is going to be true. Either Q is going to be true or R is going to be true. Meaning that if Q is true, then R is false, so then Q is true. If R is true, then Q is going to be false, then R is still true. So then at any rate, basically either Q or R is going to be true, so then the compound statement is going to be true. Now another statement is, for example, statement P is 125 is a multiple of 7 or 8. 125 is a multiple of 7 or 8. So the component statements of this compound statement, if I write them as Q and R, are basically you could say 125 is a multiple of 7, and you could say 125 is a multiple of 8. Now, of course, this is false, and also this is false. Both of them are false. So the compound statement P is false, right? Now, there is no rule to think about. Basically, these two rules that we just talked about, these two rules over here, these are, of course, two rules that we can explicitly talk about. We can say that these are the two rules that we have. But then when we talk about different situations, then there is no rule to basically to consider when we are thinking about these different situations. Meaning that, for example, when we say that two lines intersect at a point or they are parallel, for example, in this particular case, if Q is true, then R is going to be inevitably false. If R is true, Q is going to be inevitably false. So that's basically all about, and that is just only this situation here. Now this situation is different, for example. In this situation, this is false, and this is also false, and they have nothing to do with one another whatsoever, right? Meaning that Q being true or false has nothing to do with R, and R being true or false has nothing to do with Q. But we know that basically Q is false, and we know that R is false, so both of them are false. That means that P is false, okay? So that's how you can think about this. Otherwise, there is no other way, and there is just simply no other way. Now, let's go and consider another example over here. It seems that the best way to basically to just think about this situation is only the way that it's been written in the book. Otherwise, there is no other way to understand it. Okay, so now another example. These are the examples that we have had before, but the flow of material in this book is kind of fascinating. You cannot reproduce this natural flow of material, really. I'm really impressed at how easy to understand the material is, although it's actually talking about pretty complicated logical things, but the flow of material is pretty fascinating. You cannot, there is no way to reproduce such a thing. It's kind of, I don't know. I don't even know what to call it. Anyway, so we have another statement here that says that P, the school is closed. The school is closed if there is a holiday or Sunday. There is a holiday or Sunday. So there is an or over here. So the component statements related to this compound statement, if you call them Q and R, would be the school is closed if there is a holiday. The school is closed if there is a holiday, and the school is closed if there is a Sunday. Now over here you can see that the school is closed if there is a holiday. This is true. And the school is closed if there is a Sunday. This is also true. So both of them are simultaneously true. So therefore you can say that the compound statement is true based on the rule that we set. Now another example here is Mumbai is the capital of Kolkata or Karnataka. Mumbai is the capital of Kolkata or Karnataka. So, in case you don't know anything about Mumbai and Kolkata and Karnataka, doesn't matter basically if you call this, for example, P, and if you call this, for example, the component statements related to this compound statement, if you call them Q and R, if you break this down, you will have the component statements related to this compound statement would be Mumbai. Mumbai is the capital of Kolkata, and Mumbai is the capital of Karnataka. which is, of course, this is false, and this is, factually this is false, and factually this is false. So since both of these are false, you can say that this compound statement is false. Another example that we have here is we want to identify the type of ore used in these statements, and then check whether the statements are true or false. So number one is square root of 2 is a rational number or an irrational number. Is a rational number or an irrational number. Or an irrational number. So square root of 2 is a rational number or an irrational number. So the component statements here are basically, for example, if you call them P and Q, would be square root of 2 is a rational number, and square root of 2 is an irrational number. So square root of 2 is a rational number, square root of 2 is an irrational number. Of course, you know that this is false and this is true, so then this is true, right? And the OR that we have used here is an exclusive OR, of course, because if this is true, then the other one is false. If that is true, the other one is false. So the compound statement is true. So this is basically an exclusive. This is an exclusive OR. And the reason why this is an exclusive OR is that both of these cannot be true at the same time. Since both of these cannot be true at the same time, this is an exclusive OR. Otherwise, this would be an inclusive OR, right? Now, question number 2 here is to enter into a public library. Children need an identity card from the school or a letter from the school authorities. To enter into a public library, children need an identity card. Children need an identity card. From the school or a letter from the school authorities. So basically the component statements are, if you call them, for example, P and Q, P would be, to get into a public library, children need an identity card. To get into a public library, children need an identity card. So to get into a public library, children need an identity card. And Q, it would be to get into a public library, children need a letter from the school. A letter from the school. So you know that basically to get into a public library, children need an identity card, which is true. And to get into the public library, children need a letter from the school, which is also true. Both of them are true. So this is true, and that means that this OR is an inclusive OR. So here it says that children can enter the library if they have either of the two, an identity card or the letter, as well as when they have both. Therefore, it is inclusive OR. The compound statement is also true when the children have both the card and the letters. So that's basically that. Now the next question here is a rectangle is a quadrilateral or a five-sided polygon. A rectangle is a quadrilateral or a five-sided polygon. So again over here, the component statements related to this would be P, for example, a rectangle is a quadrilateral or you can say that a rectangle is a five-sided polygon. Now a rectangle is a quadrilateral is true. A rectangle is a five-sided polygon is false. Since one of them is true, then this is true, and this OR is an exclusive OR. Because only one of these is true, because if this is true, this has to be false, and and both of these cannot be true at the same time. So here OR is exclusive. When we look at the component statements, we get that the statement is true. Okay. Now what's important here, when you get into this kind of material, what's very important, very important here is that you don't make the kind of conclusion that that is not based on what you read in your book. For example, let's say that, let me give you an example. For example, in the case of this exact books that we are reading over here, these are the NCERT books related to, for example, to the education system of India, right? So these NCERT books are basically have been written in this way. You get into, for example, one topic, and then from that topic you get to some other topic, and to some other topic, and so on and so forth. Now, this is not the kind of book that, for example, you read about, for example, polynomials, and then you learn everything, for example, about polynomials in one chapter, and then you move on, for example, to, I don't know, to geometry. It's not how it works. The way that it works is that you read a little bit about polynomials, for example, in class 6, and then a little bit more in class 7, and a little bit more in class 8, and a little bit more in class 9, and so on and so forth. And the way that you can be successful with these books is that you don't make the kind of conclusion that is not based on what you read in the book, based on where you currently are in the book. Meaning that, for example, when you're reading about mathematical reasoning, for example, in this chapter of class 11 over here, now there are, of course, a whole lot of things that you can think about that would basically come to mind when you read about, for example, OR in this section over here, right? So the problems that we solved here, we already solved them. There is nothing wrong with them. But what you haven't solved, based on this, you cannot assume that for example, since you have read this over here, then based on this, then this is going to be like this, and the other, and some other thing is going to be like that, and so on and so forth, because it doesn't work like that. If you haven't seen anything here in the book yet, you cannot assume anything about it until you read about it somewhere in this book, or in some other book that you trust. Okay, meaning that, for example, one of the problems that I personally had was that I read about, for example, mathematical reasoning in one of these books. I don't know whether it was class 8, class 9, or whatever that was, I don't remember. And then there I have made this mistake that, for example, I have read something, and based on what I have read, I have assumed that, for example, okay, this is the definition, this is basically the definition of, for example, true, and this is the definition of false. Now, when I come here, I see that it's actually not so, right? And so that's basically one thing that you need to take out of your thinking. As long as you haven't read anything about something, you cannot make assumptions about that it doesn't necessarily work like that. I mean, it could be so that then that later if you read about that thing, that it could be completely different from what you assumed. So don't make unfounded assumptions about things. That's basically what it means. If you haven't read something, you just don't know it. But you're not supposed to make assumptions about it, because, well, basically all of mathematics, as you can see here, almost all of mathematics is definitions. And these definitions is not necessarily always based on logic. So that's the whole story. Now, in the next video, we will talk about quantifiers, and I'll see you in the next video.